Hello, I am Hunter. I am a biomedical engineering major in the class of 2017. In this tutorial, we will be demonstrating how to make a standard curve using Excel and explain why this curve is useful in experiments you will be performing throughout the course.
In order to demonstrate the process of making a calibration curve, we will use data from the Absorption Spectroscopy Pre-Lab. First, we will briefly explain what a calibration curve is. A calibration curve establishes a linear relationship between two variables so you can determine the value of a number you plug into the derived equation. The final equation of the calibration curve is also frequently used to determine the experimental value of constants and compare it to theoretical values. The most common calibration curves you will be using in this class and other general chemistry courses at Cal Poly are calibration curves associated with Beer's law, which has the equation A equals epsilon times B times C, where A is the absorbance of the solution, epsilon is the molar absorptivity of the solution, B is the path length, which is usually 1 centimeter, and C is the concentration. Since epsilon and B are constant values, they combine together to form the slope of our graph, or M. The y value is absorbance, and the x value is concentration. So Beer's law is really just the equation for a line. In this tutorial, we will be using the Mac version of Excel. Similar steps should be taken for Windows users.
Hi guys, I'm Alec, a software engineering major from the class of 2017. We have our data off to the side. Now here's how to put it into Excel and manipulate it if needed. The first thing you should do is title your columns. After all, you want to know what your data means, right? After you've placed all your titles, it's time to enter in the data. For example, we know the volume of the stock solution from the prep activity, and we need to use it to figure out the concentration of the diluted dye. So let's go ahead and put it in. Entering data into Excel is pretty self-explanatory, as Excel is essentially a large table. Put the data in the cell, then hit enter to go to the next cell down. When a column is filled, click the top of the next column and continue with the rest of the needed data. Essentially, you need to put the data you have in a table into Excel, so we can take advantage of Excel's features to manipulate the data. Now, we know that the concentration of our undiluted dye is 54.5 micromolar, but we've made multiple diluted versions of this dye. Thus, we need to determine the new concentrations of each diluted dye, using the formula M1V1 equals M2V2. Excel can manipulate multiple columns of data together using formulas. Since we need M2, the diluted dye concentration, our formula is going to be M1V1 divided by V2. So, let's put it into Excel. What we're going to do is type equals, then type the mathematical formula in, referring to the cells and numbers we want to make a formula out of. Now, we need to multiply this by the correct cell that gives us V1. In this case, it would be cell A2, as column A has our volumes of the stock solution we used in making our diluted solution. B2 is the volume of the diluted solution, so we put it in as our value for V2. Type 54.5, since that's the concentration of the undiluted dye. This gets us the correct dye concentration for the first run, where we didn't dilute the dye. Now, just click the cell you have a formula set up in, then click the corner of the cell and drag it down until the blue rectangle covers the needed part of the column. Excel remembers the formula you put into the first cell and does all the work for you to fill in the remaining cells. You can also mess with just one column at a time, rather than putting 3 columns into a formula at one time like we just did. For example, our concentrations are currently in micromolar, but we want them to be in molar. So, same as before, we use formulas in Excel. Just revert to the column of the concentration and multiply it by 10 to the negative 6 to convert to moles. Now we'll put in the absorbance data from the prep activity, like we did with our other data. It's easiest in Excel if you put the 2 columns you'd like to create a standard curve for next to one another. You'll see why in a moment. The data is given to us out to 3 decimal places, but if we try to just input this into Excel as is, the last 0 disappears. This can be solved if you'd like. Drag to select the column of numbers, then right-click and go to Format Cells. Click on Number and you'll see an option that allows you to extend out the number of decimal places displayed. As an aside, the answer to question 6 in the quiz is blonde.
Hello, I'm Roberto. I'm a physics major from the class of 2018. Now that you have entered and manipulated your data, I'm going to show you how to plot it. First, you need to identify your x and y variables. For this example, we want to use concentration on the x-axis and absorbance on the y-axis. Now that we know what to put in each axis, we can now plot our data. First, we need to tell Excel what to plot. To do this, you can click and drag over the data you need to plot. Now go to Charts, and click Scatter and mark Scatter. Now we have our curve. You can click and drag it to move it, and you can also resize it if you need to. You can delete the legend by selecting it and hitting delete on your keyboard. You only need it if you have multiple curves in one graph. Now let's label our axes. Go to Chart Layout and click on Axis Titles. Select Horizontal Axis and Title below Axis. Since we said that concentration was on the x-axis, let's use concentration to label this axis. Also, don't forget to add your units. In our case, we're measuring concentration in molar. Now do the same thing for the y-axis. Just make sure you select the rotated title. Now let's add a title. Go to Chart Layout and Chart Title, and select Title of our chart. Make sure to add a descriptive title, not just Y versus X. Now, hopefully you've noticed that the points follow a linear pattern. That means you can fit it to a straight line. To do this, we need to add a trend line. Go to Chart Layout again and add Trend Line, and select Linear. What's useful about having a line is that we can now easily describe it with an equation. Excel can do this for you by right-clicking on your line, go to Format Trend Line, go to Options, and make sure to click Display Equation and the R-square value. Now, the trend line equation is the most important thing about these kind of curves. If you have measured one of the two variables, you can get an estimate for the value of the other variable using this equation. Now, notice how our line has a y-intercept. Sometimes, theory tells us that the y-intercept should be 0, but our lines will have 1 most of the time. Usually, this intercept will be so small that it won't affect our calculations. As for the R-square value, the closer it is to 1, the better your points fit the linear trend.
Hello, my name is Alex, and I'm a materials engineering major from the class of 2018. Hunter, Alec, and Roberto just walked you through all the steps necessary for creating a standard curve. Feel free to go back to any section for further clarification. Your final curve should look something like this. Some final notes. Remember that a standard curve can be used in many situations and for various data and equations to relate data. This type of curve is not exclusive to Beer's law and absorbance or concentration. A similar curve could also be used for emission data, graphing inverse wavelength, and to determine Rydberg's constant from the slope of an equation of the line. Keep in mind, whenever you make one of these curves, to label your axes and title the curve. Without this, your chart is meaningless. Does data 1 versus data 2 mean anything to you? Also, make sure you show your equation and the r-squared value. The equation is the goal, and the r-squared value lets you know that you did it correctly. Remember that while we did this on a Mac, which are available to you in Studio, the steps should be similar for Windows users. This therefore concludes our tutorial on how to create a standard curve in Excel. If you should have any further questions, please feel free to ask your instructor or a learning assistant. Good luck!